Welcome to my basement. Why are we here today? Because I wanted to discuss this, my new Rheem heat pump water heater. Some of you may be familiar with these, some of you may not. It's essentially, this lower portion is a tank, like you'd see on practically any other tank type water heater. But this upper portion is more or less sort of a repurposed window air conditioner unit. But rather than expelling the heat that it is pumping from inside your house outside, it is expelling the heat into the tank, creating hot water. So it has some interesting side effects. One is this outlet here blows out cool, dehumidified air. So nice dry air, which you can imagine in a basement, particularly in the humid south, is probably a nice thing. I have living space above me, so keeping this area cool and dry is a real benefit of this that I wouldn't get with a electric resistance water heater, which I generally would never have, or a gas water heater. So it gives that benefit. It's also very energy efficient because it's not generating heat, it's moving heat. So it's pulling heat from the air around and dumping it in there. It's almost creating 4 units of heated water for every 1 unit of electricity that it uses. Now, again, that's not creating heat. It's moving the heat from around and thus cooling and dehumidifying the air around. It does have a byproduct from that. That's condensate that comes down this and drains down. As you can see right now, I have it set at 120 degrees. Above 120 degrees, you are able to scald human skin relatively quickly. So that's what we keep it set at right now, though it can go much higher. I believe this one can go into the 150 degree range. So at some point, I'm going to create a connection between the hot and cold water lines such that the hot water line here has a thermostatic mixing valve. What you want to look for is an ASSE 1017 compliant mixing valve. And what that'll allow me to do is if I have 150 degree water in here, it will add just enough cold water to bring the cold water, or rather to bring the hot water down to 120 degrees, which is generally the temperature you're going to want supplying your shower and whatnot, maybe even a little bit cooler. Though you never want to go less than 120 degrees in your tank, because that is starts to get you into the range that Legionella, the bacteria that can cause Legionnaire's disease, becomes very, very comfortable in the below 120 degree range. So really, for health reasons, you want to be above 120, but also by getting this up to 150 and adding the mixing valve, I'm going to really extend the capacity. This is a 55-gallon tank, but I'll be able to reach equivalents of like an 80-gallon capacity by adding that mixing valve. So I can provide some specific details. Maybe I'll put it in the comments down there, or maybe I'll just put it in the description on how much ratio. During the summer here, we can have tap water coming in. 75 degrees is not an uncommon temperature for tap water. And during the winter, we rarely get below 65, 64 degree tap water. The coldest days, I particularly might, because some of my house isn't over this basement, it's over crawl space. So I might get some cooling of the tap water. But that temperature range of, you say you were even at 60 degrees, your tank, 60 degree water coming into your house, your tank had 150, then you're going to get a nice extension of roughly 1/3 extra capacity to this by mixing in cold 60-degree water into 150-degree outflowing water, rather than just having it just set at 120 and using purely that. You can even up here, there's a box, put a unit up here that can respond to electricity rates. If you have a time or demand based electricity rates, and if you want to say normally keep this at 120, 125, 130, but when electricity rates get really cheap, or in some places even like they pay you to use electricity, then this hikes up to 150, and you do all of your water heating when the rates are most favorable. You can get a unit that goes up here. It's not inexpensive. I think it's like $150 or $200 to add that unit up here. So I wouldn't do that unless I could prove that the cost benefit would pay off from those variable rates for electrical usage. But that's an option, especially in a place with high energy costs. Good option. As it is for me, switching to this heat pump is only slightly less expensive than natural gas. Our electrical rates here are not very high, but I see, particularly in the wintertime, there has been lots of fuel surcharges, fees, and whatnot. And I think the natural gas is going to become something that, particularly when you have incidents like what happened in Texas in 2020, having this will be more beneficial. And you say, well, what about power outages? Well, again, this goes to that sort of like energy independence model. Like if you have solar panels or wind on your property and you have a battery, you can store that. It does give you a little bit of independence and less reliance on the outside. And particularly if you can store 150-degree water in here, even if it's well insulated, and even if that drops some, you probably have hot water. And more importantly, you have just a reservoir of non-frozen water here. I could add lots of insulation to this area, also further protecting this. And really, again, I can stretch that with that use of that mixing valve. Hey y'all, just wanted to interject here with a couple quick things before I get back to the video. First off, I discussed the effective capacity of your tank with the thermostatic mixing valve. Made this quick little table to demonstrate. So these are hot water temperatures in your tank, 120, 130, 140, 150, 160. I don't think that the one I have goes up to 160, but if you get it used to be called the Sandco 2 or something like that. It's got a different name now, but it's essentially a same unit. It's a split system where it's pulling the heat from an outside, looks like an air conditioner compressor style unit, particularly like the kind you would see on a mini split or a VRF system. That one I know can go north of 160 degrees. It's also a very expensive unit. So it gives good comparable cost savings if you compare it to electric resistance. But this one just really seemed to provide, comparing the Sandco 2 to the Rheem, this one seemed to give a better bang for the buck dollar value. Though that one has a stainless steel tank. The Sandco 2's tank is it's gonna last a very long time. So it might have that durability, longevity aspect. So that's why I included a 160 here. Here's a range of cold water temperatures. I know some parts of the U.S. Might get temperatures in the 40s coming out of their tap. I don't know how prevalent that is, so I went with a range that I know are common. I know people get 50-degree water. I know I get 75-degree water. So I gave this range here. cold water temperatures mixed with hot water temperatures, and this field here gives the effective capacity of your tank. So if you have literally no cold water mixing in, your 55-gallon tank that you have here produces 55-degree water 55 gallons of water. 55-gallon tank, that one's simple. So as you start to increase the temperature and mix water in, and warmer water, you get extended capacity. So if I had my tank set at 150 and I had 65-degree water coming in, that's where I got the 85 gallons of effective capacity. So I wanted to discuss where I got that number. If you can get up to 160 and you've got 75 degrees coming in, you could get 104 gallons of effective capacity. In any case, all of these show the benefits of having a well-insulated heat pump water heater that can get up there beyond the health effects. A couple other quick things to touch on. My installation cost was more than my water heater cost. I had a water heater failing, and you never want to be replacing your water heater in the emergency situation. I was. And I was also relocating my water heater. It was in one location that I wanted to get it out of to decrease my pipe lengths, because I was actually wasting a lot of water waiting on the cold water to drain out. Another way you could potentially save money on hot water is to get a recirc pump. It's hard to prove the cost benefit of those. It's going to take a long time of using those to recoup the cost of the water going down the drain. But maybe if you're doing new construction, you're already doing work, you can make that benefit, particularly if you have a lot of people taking a lot of showers off of one trunk line. That might work. Next thing I touched on briefly was energy independence, electric versus gas, and I even brought up the event in Texas, which reminded me that in that 2020 winter storm event in Texas, that a lot of natural gas actually went out because they didn't have the electricity to pump the natural gas, among other reasons. Not saying that natural gas isn't useful, but you're relying on someone somewhere else to provide you. And that's something you should have a backup plan for. After Hurricane Ida, there were people I knew running off of natural gas generators, and the gas pressure was dropping rapidly in that particular municipality from that utility provider, and it made their generators frequently stop and sometimes unable to start back up. So low gas pressure can be an issue. So I just wanted to touch on those things. I'll return you all to the video, but thanks. Back to the video. It's there it's kicking on. So you'll be able to hear the the volume that it operates at. It does get a bit loud, probably quieter than most window units you've heard, because it's a modern, efficient appliance. But I just wanted to discuss this with y'all and show this step that I've taken, and just share this bit with y'all. So I'm gonna get going. You can hear it running. So I'll ask you, go ahead and hit like, hit subscribe, hit the little bell for notifications, do the internet video thing, click all these so that algorithms whizzing and whirring on computers and data centers know that this is good content, and that you and other people like you should be shown more of this. So thanks for watching. Hope you've enjoyed. Have a good one. Bye.